In this video, we're going to take a look at colligative properties. And a colligative property is a property that depends on the amount, not the type, of substance. And there's going to be four main colligative properties that we're going to look at in this chapter. The first is vapor pressure lowering. And basically, we can say that partial pressures exerted by solvent vapor above solution, which is PA, equals the product of the mole fraction of the solvent, which we abbreviate XA, times the vapor pressure of the pure solvent P naught A. And Raoult's law expresses this for us by saying PA equals XA times P naught A. And this is the relationship that you can use to solve for a vapor pressure lowering. The second colligative property is boiling point elevation. And at 760 torr, or 1 atmosphere, pure water will boil at 100 degrees Celsius. But if we change, we can change the boiling point of a solution versus the boiling point of a pure liquid. So if we change what we dissolve in that water, we can change its boiling point. And the expression here is going to be delta TB, or the change in temperature of the boiling point, is going to equal KB times the molality of the solution. And KB here is going to be the molal boiling point constant. And typically, we can say that the boiling point of a solution is higher than that of a pure liquid. Okay? In addition to manipulating a boiling point, we can manipulate the freezing point. But here we call this freezing point depression. And the freezing point depression formula is going to be very similar to our boiling point elevation. It's delta TF is going to be equal to KF times lowercase m, where KF here is equal to the molal freezing point depression constant. And we can say that in contrast to the boiling point here, the freezing point of a solution is lower than its pure liquid. So this leads to boiling point elevation and freezing point depression. The last colligative property we're going to discuss in this chapter is called osmosis. And osmosis is the net movement of solvent through a semi-permeable membrane toward the solution with greater solute concentration. And this can kind of be expressed very similar to the PV equals nRT expression, except in this case we're going to use the Greek letter pi to be the pressure required to prevent osmosis. And we can take that PV equals nRT expression and manipulate this to say pi equals N over V times RT. And here we've been talking about various pressure units or various concentration units, and here if we have N over V, which would be moles over liters, we can say that pi can also equal capital M, which is the molarity, times RT. Okay, so these are the various colligative properties, and in addition to looking through all of these, if we had any one of these colligative properties, the molecular weight can be determined by using various conversions. So we'll go through a couple example problems of these colligative properties here in the next couple videos.